Quick review. We're taking our dilutions, putting them into the colorimeter, and taking a reading using the LabQuest. The last sample that I put here in the colorimeter in the cuvette was 2 milliliters of my original dye, 8 milliliters of water that had been well mixed. That's an important part. Now, the screen has had time to stabilize, and it's reading 0.529. So I'm going to keep, right here's the keep button, I'm going to keep that point, and I'm just going to say that this is a 20% dilution. I hope I've gotten my numbers right, but I think you get the idea that there's 20 milliliters or 2 milliliters of the blue dye for every 8 milliliters of water, always 10 milliliters total. And I'll say, okay. Now, when I take that, notice that now there are two positions that appear clearly on the screen. All right, going back to the cuvette, I'm going to open the colorimeter. I will make sure that I am sucking out the liquid that is in the cuvette. Cuvette is C-U-V-E-T-T-E. You don't want water or dye dripping down the sides. I'm going to go to my third sample, which was 3 milliliters of dye, 7 milliliters of water. I need to make sure that I have enough so that the cuvette is filled enough so that the light is going to pass through the sample. I don't want to have it passing through a ridge there. All right, I'm closing this. Now my readings are changing. You can see them changing here. And it's fluctuating a lot, but it's starting to settle down, and it's reading 0.642 or 3. Good enough. I'm going to hit keep. I'll now put in that I have 3 or 30 up to 100 or 3 to 70, 3 to 7 milliliters. And then I'll say, okay. Do you notice what's happening? Look at my graph changing. Now I have 3 points that show up, plus the 0 point. We went through 0, 0, because the water read 0. So now I've got 3 data points. I'm going to go back, and I just repeat this process. So let's just watch, and I'll give you the readings. The 3 milliliters come out. The 4 milliliters of dye up to 6 milliliters of water with 6 milliliters of water goes in. Make sure there are no bubbles. The readings are fluctuating now, but it's reading 0.707 pretty consistently, 0.709. All right, I'm going to keep this. You're going to have a little fluctuation, but not a lot. I'll put in that this is 40 milliliters to 60, or 4 to 6 in the combination, and say OK, and the new graph appears. One last data point. You know, sometimes people might remove the cuvette. If you're very careful not to get any of the liquid down into the colorimeter, I think this is preferable. Why? Because it's important as to how the cuvette is actually sitting in the holder. If you take it out and put it back in, you might change the orientation. That would change the path length of the light passing through the sample, and that might alter or make changes in your experiment that you would have to deal with. Again, there's fluctuation on the screen, settling down at about 0.4, 0.458 or 9. It's pretty consistent now. I'm going to keep that. And my last value I read here was 40. So I know that this was my 50-50 mixture. 5 milliliters of water and 5 milliliters of the blue dye. So I'm going to say okay. And look at the graph that we have. Now, I've done my measurements rather hurriedly to show you how you want to make a cereal dilution, how you want to think about putting it into the colorimeter, and how you want to get your readings from the LabQuest. Do you have to do it exactly like this? No. Maybe your thought is to do 10 tubes, diluting 1, 2, 3, 4, 5 milliliters up to 10, etc. You might say, well, I don't need all those data points. Maybe I'm just going to do 1, 3, 5, 7, 9. Maybe you want to do a pure sample, cut it in half, and then go down from there. So there's lots of ways that you can approach a dilution. The idea is this. You have a graph now. And if you look at the screen, something that I could do is this. These data points are in there. I hope you wrote them down, but what if you didn't? There is, up above, some choices. Here we're on a graph, but you could go to a data table right here. This is a data table, and if you click here, what it's going to do is give you all your readings. Here it reads 10, 20, 30, 40, 50 milliliters. I'm sorry, 10, 20, 30, 40, 50, which is my dilutions. And then it gives me, look at this. This is transmittance. This is absorbance. We need to talk about this in class, but when you have 0 dye in your sample, then your transmittance is going to be 100%. All the light goes through. Where if you add blue food coloring, the red light is going to be absorbed by the blue. You can see that your absorbance is going down every time I have more blue molecules in line with the red light passing through the cuvette. Absorbance is a little different. Absorbance is logarithmic. So what you see here is a little bit harder to interpret, because here what is being absorbed is going to increase as more and more dye are added to the samples. And it's not as easily predictable what the values will be, since it is on a logarithmic curve, and most of you have yet to study logarithms. I want you to think about how the appearance of the curve should look. And then before we end this video, let's just say one more thing. The best thing I can leave you with is that your measurements are critical. You have got to use so much care when you measure 1 milliliter, or 8 milliliters, or 5 milliliters. You must be reading from the bottom of the meniscus. You would make sure that you eject all of the liquid in the pipette if it is a to deliver. And if it's not a to deliver pipette, that you go right down to the mark which marks the volume you want. Another thing that you cannot do not tip your pipette like this. There's nothing worse than having an acid or a base or some caustic substance here in the pipette draining down into the pipe pump. It's going to erode the pipe pump. You're going to have all kinds of residue there that's going to make terrible, terrible data for future experiments. Always keep the tip down. Are these all the things you need to know about setting up for this experiment? Probably not. But I'm hoping that if you pay attention to this videos, since it took a little bit longer, that you'll come in a little bit better prepared to do the law that we're involved with now. So if we want any justice for our justice, we had better really take good measurements. How will it end? Well, it's going to end like this. What was the volume, or the ratio, in the can? We don't know. But we have this unknown sample because I've just squirted some amount and I didn't even tell you how much is there. Now, if you look at it, you can visually inspect it and see that it's more concentrated than the first tube. But we need to know more than that by comparing it visually. Is it going to be there or is it going to be there? Well, it looks to me like it might be between these two tubes. But when you have a graph, you can take the absorbance of your unknown and you can solve for its concentration. You simply take this dilution, put it into the cuvette, compare its readings on the graph that you have from the LabQuest. We'll do that in class. So think about doing your dilutions properly. Think about how you want to use the cuvette and the colorimeter and the LabQuest so that we can get to our data.